So, in the last class we stop at this point that what will be the content of the cache if we use set associative memory. So, if you understood that part, so next we proceed next part, but within the title is like memory organization we are talking about. And there are two factors. One is it should be performance in terms of that it should be fast, and secondly we invest the minimum amount of money. Okay. So, therefore, objective for any performance measures for computer system, we want a system where system will be fast with investing minimum amount of money. Okay. So, therefore, system should be faster as well as price also will be low. That is the main objective. So, as you know that I said many times that processor is much faster with compared to the other slower device like memory and the IO device and so on. And that is why that cache is introduced in between main memory and the processor. And some of the caches you know that L1 caches mostly it stayed within the processor. Okay. So, other caches like L1 and L1 cache is mainly the splitted cache. In a sense ki, the data and instruction we know that which one is the data and which one is the instruction. For them actually it will have the separate cache. Okay. So, that the instruction hit will be maximum and the immediate data also will get. Okay. And the rest of the cache in general in together, that is data and instruction will be in the same cache. Okay. That we will see later, but today what we will be talking about, that is something called memory interleaving. So, even though we have a slower device, okay, but if you access the slower device, multiple slower device parallelly, so then obviously it can match with the speed of the processor at least up to some extent. So, that is something called memory interleaving. So, book remains same, that is the amateur, and then today I will be talking about memory interleaving. So, what is the idea of the memory interleaving? Before that we will see as I said in earlier classes also, to build a big memory system, what ideally we do, we combine the smaller memory unit. We have seen earlier in the class that if you have a smaller memory unit, 3-4 smaller unit, we can make a build a much larger memory unit. Okay. So, in the same way, if we have the organization of the memory in a different way, so we can access the different location simultaneously. Okay. So, that is something called memory interleaving. So, before that, let us say we have a memory module here. Let us say this is one memory module, and each memory module generally will we have two register. One is called address buffer register, that basically by which actually we identify that which location CPU wants to access. Another is called data buffer register. I am talking about inside the memory only here. So, what happened in the data buffer register, say suppose CPU wish to access this particular, so this particular word, then the memory system actually it will place the word into this register, that is called the data buffer register. And if CPU wish to access this particular location, then actually that data should be placed, that information, that address should be placed here, by which actually it will identify it is the location from where the data should be retrieved. Okay. So, therefore, there will be for each memory module there will be two register, one is called address buffer register, another is called data buffer register. Let us say we have 4 module here, similarly we will have a module here, we will have a module here. Okay. So, address buffer register and data buffer register, similarly here. Now, what happened? Let us say this is module number 0, this is module number 1, module number 2, module number 3. Using we can make much bigger memory system. Okay. Let us say it has 8 locations. Similarly, it has also 8 location, it has also 8 location, and it has also 8 location. So, total will have 32 locations. Okay. And each location is 1 byte. So, let us say then we will get the 32 bytes if we combine this 4 memory module. Okay. So, 32 bytes means so to identify each word, that's because CPU will generate the address of the entire memory module, not the individual one. Okay. So, then it needs 5 bits, right. So, therefore, that whatever the CPU generate the address, that is the main memory address here. So, that will be divided. So, it is a 5 bits only. Okay. So, what this example I am talking. Okay. So, this is 5 bits. So, these 5 bits will be divided into 2 parts. One will identify that which memory module, and another one will identify that location within the memory module. Okay. Let us say if you have a location like let us say 1 0 0, and then location is, this is too long. So, let me tell, yeah. So, location is less 1 0 0 and 1 0. So, we have to identify, first we have to identify the which module. So, what we can do it, we have two style, but in the first one what we can do it, that upper significant bits, okay, or we say is the more significant bits we can use for identifying the module. Okay. So, we have here 4 modules. So, then we need 2 bits only. So, therefore, this 2 bit will indicate that which module, and then this bit will indicate that location within the module. Okay. So, therefore, this let us say k bits, in case here is I wrote likely 1 0, right, I wrote 1 0, and then I wrote is, anyway I can write 0 0 1. So, this will identify the which memory module, and this will identify that lower part will identify the location within the module, and this will tell you that which module. So, here 2 means it will identify this location, and then within this one we know that it has 8 locations. So, then it will identify the 5th location, 101 location. So, then what we can do it here. So, this connection, so this will be attached with, this bit will be attached with a internal decoder, as I said in the earlier class, because what is that decoder. So, let us say this will be 2 to 4 decoder, 2 to 4 decoder here, and then 4. So, it will select the any one of the module. This will select module 0, this will be connected with module 1, this will be connected with module 2, and so on. Okay. So, instead of showing this detailed circuit, what we can show it here. So, this particular bit, let us say k bit, will identify that which module. Here we can go here, we can go here, and this one will identify to the location within the module. So, this part basically will be connected with, so you can have with ARB, ABR. Okay. So, you can have something like that. So, this will be connected in this portion. Okay. So, mostly what I wanted to tell you. So, this k bit will be connected to identify any one of the module, and lower bit will, lower bit will identify the location within the module. Okay. So, then you will get a complete memory module. Okay. But problem with it is that if you wish to access the consecutive memory location, if CPU wishes to access the consecutive memory location, so all memory location will be within the module. Okay. So, because that consecutive lower byte is indicating the location within the module. So, therefore, all location will be within the module. But what we want, ideally we want that multiple module will work together to match the speed with the CPU. So, when this one is working, simultaneously this one also will work, and so on. So, CPU will generate only the address, and if it is the address of a block, starting address of a block, so consecutively it will identify the location, system will identify the location, and it will retrieve the entire block from the main memory to the cache memory. Because as I said earlier also, CPU will only refer a particular word. Now, entire the memory system, what it will do, it will identify it belongs to which block, and entire block will be transferred from the main memory to the cache memory. But CPU wants only one word. Okay. So, therefore, it will identify which word. First, it will tell that which word it wants to access, that CPU, and rest of the circuit, that is the memory module circuit, it will consecutively access the other locations because it is within the block, and then it will be transferred. But here what happened, that all consecutive locations appear in the located within a module. So, therefore, only one module is involved. What do we want, that multiple module, we can access the multiple module at simultaneously. So, that block transfer will be much faster than earlier one. So, that for that actually we need to have the interleaving. Okay. So, what is interleaving now? So, interleaving is very simple, it is you do on the other way. So, what we did in earlier, to identify the module, we use the higher order bits of the address, right. So, we will do in the reverse way. What we do, we will use the lower order bit to identify the module, and we will use the higher order bits to identify the location across the module, not within the module, across the module. Okay. How it will work, with one example here. So, let us say here what I said, again we can take the same example here. So, we have a memory module, we have another memory module, and for simplicity we consider that each module has 8 locations. So, problem remains same. Now, what we will do it, lower order will identify the memory module. So, therefore, earlier what was the address? So, 10101. So, 01 and then 101. Okay. So, we have 4 module. So, then if lower order means only 2, this will identify the module. So, this part will identify the module, and this will identify the location within the module or across the module. So, let us say you have here address buffer register and data buffer register, similarly address buffer register, data buffer register, address buffer register. Now, 01, what is the objective? That entire block will be transferred much faster way compared to earlier. So, entire block that should be in consecutive memory location. So, let us say memory location starting from, instead of 00, so we should say is 0, let us say 00. CPU may access, see 01 also is no problem. Okay. So, now first what you do it, what are the consecutive memory locations? So, consecutive memory locations are 101, 01, 101, 10, 101, 11, 10, then it will be 1100. Okay. So, then 11101, 11110, and say let us say 10100. 1 1 1 1 1. Okay. So, these are the consecutive memory location, let us say. Okay. So, now what will happen? So, this will identify the memory module. So, this one is 0 1. So, this is 0, this is 1, this is 2, this is 3, and this one will identify 101. So, 101 means within the location. So, let us say it is somewhere here 101. Now, CPU will first tell this is the word I want. Entire memory will understand, okay, this word basically is locating in a block, that is in a memory module, that is 01. It is not only CPU may access, as I said, the locality of reference, spatial locality. CPU may access the next location also. So, next location is where? It is in different memory module, not in the same memory module. So, therefore, what will happen? CPU will only issue this word, but rest of the thing will be identified by the memory module, that it are basically those locations, consecutive memory locations are across the memory module. So, therefore, each memory module can work parallelly. So, in this example, what will happen? 101 is here, next is also, say this is the 0th memory module. So, just before that, because it will be in the within a, all consecutive locations will be within a module, within a block. Okay, when you transfer to the CPU, you will transfer to the cache. Okay. So, therefore, this one is 101, next is also 101, this one is also 101, but if you see here 101 00 indicate in memory module 0, 0101 indicate memory module 1, and 10110 this indicate in the memory module 2, and this indicate in memory module 3. That means, what happened? They are located across the memory module with the same address within the location. Here is also 101, here is also 101, here is also 101, here is also 101. So, now next I think here I did mistake, 10, 10, this will be 10, this will be 10. So, after this one, so after accessing this part, what happened? Again it is the next memory module. So, it is 00, so 00, 00, but here next location is 10. So, therefore, 110, 110, 110. So, next location is itself is 101. So, if you wish to transfer 8 word, so 8 word will be transferred in 2 go. In a sense, in the first it will access, while accessing this part, at the same time it will be access this portion, it will be access this portion here, this portion will be accessed parallelly, because each will work independently. Okay. So, this will be placed here, this will be placed here, this will be placed here, this will be placed here. Now, after transferring this data to the CPU or this data to the cache memory, because these all are the memory module. So, next this portion next will transfer here, while transferring this one is here, at the same time second module also will transfer the next location to the DVR, and so on. So, instead of in earlier organization, what we had only one data or one word in DVR in a module, but here we will get the, see, accessing time is 2 seconds, after accessing after 2 seconds we will have the 4 word in different memory module, and because CPU is much faster, so therefore this thing will be can be transferred in much faster way. Okay. So, let us say transfer time from this register to CPU is, so let us say 1 second, so it will take 4 seconds. Earlier what you had to do, so one it place the data on the DVR, so it should be transferred, then only it will place the data to the DVR, then only it will transfer, and so on. So, therefore, this strategy, the second organization is something called the memory interleaving, because more than one module are working together to match the speed with the CPU. Any doubt? Next we will go with one example. why just now we told, maybe you missed it. So, in the first case what happened, what do we want basically? Objective, as I said, that we have to match the speed of the CPU with the, we have to, because memories are much slower than the CPU speed. So, we have to match. How we can match it? So, if you will do the multiple thing for the slower device parallelly. So, earlier case, if we identify, if we identify the, to identify the memory module, if we use the higher order bit, then what will happen? We can only work with within a module, so we cannot use the other module. Why? So, because the address are, we very likely the address will be accessed consecutively by the CPU. Okay. So, therefore, we cannot do the parallel access, but if you do the reverse way. So, why happen is actually, if you see the lower bit is changing very frequently. What is the next one? Lower bit is changing. For that one, we use the lower bit to identify the module. So, therefore, this lower bit, it will go to the different module, and you see that if you access these 4 addresses, so higher bit is not changing, only changing the lower bit. So, those lower bits we use for identifying the memory module. So, those actually basically the address of the different memory module. Okay. As I said that when CPU wants to access a particular word, it is not the word memory module will send, it will send the entire block where that particular word exists. That means, the block consisting of that particular word will be sent from the main memory to the cache memory, because that locality of reference. Okay. So, now what I do it, I will give one simple example, that to show that why that this system, that interleaving is faster than the earlier technique. Okay. So, here I need to write something. So, some assumption, let us say CPU generate the address, CPU wants to access a particular word. So, CPU will generate the address, and it will be, that address should be sent to the memory module. Okay. So, let us say here sending address by CPU to main memory, it takes 1 cycle, okay, 1 clock cycle. Now, what happened, that to fetch first word from the, here we had memory module. So, it is address buffer register and data buffer register, and this is, you can consider here we want to access data from here. So, it is assumed that for fetching the first word within a memory module, it takes 8 cycle. So, therefore, to retrieve first word from the memory module to DBR, it takes 8 cycle. Okay. So, what should I write? It is like to fetch a word from a location in MM2 DBR, it takes, so let us say 8 cycle, clock cycle. Next, consecutive word within a module, it takes half of the earlier. So, if first takes the 8 cycle, maybe next, because it is in the next location, so it takes lesser time. So, to access consecutive location, it takes, let us say 4 cycle. Now, data will be transferred from here to CPU, so it takes 1 cycle. Okay. So, sending one word to CPU, it takes 1 cycle. Now, we want to transfer data from memory module to cache memory, 1 block, and 1 block is equivalent to 8 words. So, size of 1 block or size of block is 8 word. So, what we want to say ki how long it will take if we use the earlier scheme, and how many cycle it will take, how long in terms of cycle it will take if we use the interleaving fashion of memory organization. Okay. So, what are the here? So, we have here CPU will generate the address, and then we have a memory module here. So, address buffer register, data buffer register. So, sending address by CPU to main memory is one cycle. So, after generating address, let us say 101 and 00, okay, or let us say starting location you take 00. So, what will happen? So, after this one it will identify okay, yes. So, then it will send this one. So, for sending it will take one cycle. After that, if we use the earlier organization, that means all 8 words will be within a memory module. Okay. So, then how many cycle that organization will take? So, first its sending is fixed, that is one cycle, and then to fetch a word from a location to DVR it will take 8 cycle. So, that is first word it will take 8 plus, then consecutive each word will take 4 cycle. So, how many another word? 7. So, it will take 7 into 4, 7 into 4, and then something for sending the word. See, first try to understand the problem. What we want to do, we have a memory organization just like this one. We want to transfer a block of data from this memory, that is the main memory, to the cache memory. So, what is the underlying situation? Underlying situation is that CPU will send the address to the memory module. For that it will take one cycle, as I said, and next consecutive cycle if, location, if it once you identify the location, now first word it will take 8 cycle, and after placing the data here, it will be transferred here to CPU. Okay. For that it will take one cycle. Okay. So, that it will take one cycle, and next consecutive locations means within the module it will take 4 cycle. This is the problem. So, first is we understood, this one is also we understood. Next is once we place the data, so that also has to be transferred by the CPU. But thing is that, so this will take another cycle here, okay. This will take one cycle, and next again 4 into 7, and then each time again you have to transfer it, okay. So, again it will take 7, and then this will be the total, but that is not the correct way. Why? When CPU this one is placed, then memory is done. Now, it is CPU responsibility to take out the data from this one to this one CPU. That work can go parallelly. So, while transferring data from this location to here or this location to here, if data is available, that will be transferred parallelly. When working from here to here, at the same time it can work from here to CPU. So, therefore, this time will not be considered, because after placing the data, now it will go for placing the data from the next location, and it will take 4 cycle with, but CPU will take only 1 cycle for transferring data from DVR to the CPU. Okay. So, therefore, that time will not be counted. So, but here I said ki it will take 7 cycle for transferring data from here to here. This is wrong. So, then what will be the right answer? This will be 1. Why 1? So, 7th will be transferred, but last one 7th will be transferred in a sense ki CPU speed is much faster because it is taking 1 cycle. So, there will be no data to transfer, while there will be last data to put in DVR, and their data only will be transferred by the CPU. So, that 1 second will be included here. Try to understand here. So, this will be total how much? So, this is 0. So, 38. Why 38? Why this one? Did you understand this why 1? No. See what happened here. See, data is getting transferred here to here and from here to CPU. Let's say we need to transfer 3 word. Okay. So, then first word it will take 8 cycle and data is available here. Now, CPU will take 1 cycle while it is taking out the data or what, it takes 1 cycle, but to fetch the data from next location to this one, it will take 4 cycle. So, within the 4 cycle CPU is completing its work. That means transferring data from DBR and transferring data DBR to CPU and transferring data from memory location to DBR is happening parallelly. And for the second case, for transferring data within the memory module to memory module, here to memory DBR is taking 4 cycle, but here it is taking 1 cycle. If it takes more cycle, then that will be maximum of these 2. Okay, sorry, minimum of these 2 will be counted. So, minimum is 1 and 4. So, that 1 unit comes within the 4 time cycle. So, therefore, that won't be counted. Now, so therefore, 8 plus next 4 and the last data. CPU is waiting for the data, but there is no data because it takes 4 cycle. For third one, it will take third one, it will take 4 cycle, but there is no data. So, then that also will be included here. After placing the data in DBR, then only CPU can retrieve the data. So, therefore, again CPU will take 1 cycle. So, therefore, this one will be included, whether it is a 8 word, 9 word, whatever this one. For the last word, CPU has to wait because there is no data to transfer from DBR to CPU. So, therefore, this one will be included here. Why 1? This is very simple, right? Is 1, 8 and 7 into 1. Okay. But in between CPU is getting transferred, but that time is much lesser than parallelity is happening. So, if you say, is very simple example, let us say time duration is 3 hour exam. If someone complete early, so he will be waiting if teacher does not allow to leave this place. It is the same way thing, until or unless that data is available into DBR, so it cannot transfer. So, CPU is done with the all 7 word, but CPU is waiting for the 8th data. Once 8th data is available in DBR, then only it can transfer. So, therefore, last transfer is happening after transferring data to the DBR. So, that is why this one will be included. What is the logic? So, that is actually in DRAM, what happened is actually to identifying the first location, it takes time. So, after that it is because it is consecutive, so it takes lesser time because it is within the module, so that is why it is taking lesser time, because it will just simply add the next time, it will adding within the consecutive. First it is identify, it takes much higher time, but next it is constant time. So, now if you not satisfied with the answer, you may be, so then you have to go in details organization of the DRAM, detail circuit. Okay. So, why it is first time it is taking and next time why it is not taking? Okay. Then you have to go, because answer is like, because within the module, so no need to go other one, but and it is a consecutive one. So, as I said that when CPU identify the location, it identified the module immediately, and after the next consecutive location it takes much lesser time. So, that is why it transfer time is also lesser. Otherwise, again you have to go to the detailed circuit of the DRAM. Okay. So, now we come to the next problem, is like when we have a interleaving. Okay. So, what time it will take for interleaving situation? Interleaving situation is like what interleaving? So, all memory module will work simultaneously. So, therefore, first is address will be transferred. Once address is transferred, it will system will identify that each memory module will be accessed. What here is first word from the each memory module, that will take 8 cycle, right. So, it will be 1 plus 8, and these 8 cycle, it is not for form 8 8 8 8, because it is working simultaneously. So, therefore, after 8 cycle there will be 4 data across the different memory module, okay. And then it will go for accessing the second memory module, and these 4 data CPU will transfer one by one. How long it will take? 4 data to transfer? 4 cycle. But while transferring the data from DVR to CPU, at the same time second word will be transferred from the each memory module. So, therefore, 8 plus 4. So, 4 for accessing the second module from second word from the memory module to DVR. Okay. So, first is already transfer. Now, you have the second word, that is 4 word in the 4 DVR, and each one will take 1 second. So, how many time, how much time, how many cycle it will take? For each word it will take 1 cycle. So, you have the 4 word, so it will take 4 cycle. So, therefore, it will be another 4. There is no plus 1. So, it will be total 17. Why 17 cycles? I repeat. So, this is the first is for sending the address, no doubt. Now, what happened in the, you imagine the second organization, where that you can have access the consecutive location, you have access in across the module, okay. And for first word is across the module means it is the new module. So, each module will take 8 cycles, and after 8 cycle actually 4 words will be available in individual DVR. So, therefore, this is 8. After placing the data, those data needs to be transferred to CPU. So, at a time only one word will be transferred and it takes 1 cycle. So, it will take 4 cycle, but while transferring the data from DVR to CPU, at the same time second word of the each module is getting transferred to the DVR from this location to this location. So, that will take 4 cycle. So, that is 4. It is not 4 plus 4 8. So, if it is stop this individual module, and then obviously it will take the 4 and then again 4, but that is not happening. While transferring this part to here and this part to here is happening simultaneously, this is taking 4 cycle, this is taking 4 cycle. Earlier what was happening? We are only transferring only one word. So, that is taking 4 cycle, but this is taking 1 cycle. So, that is why this second 4. Now, first word is transfer from DVR to CPU, and second word is also transfer from memory module to DVR. So, now data is available, another 4 words is available across the 4 memory module, that needs to be transferred to CPU, and for each word it will take 1 cycle. So, therefore, 4 word means 4 cycle. So, therefore, if you have interleaving, it will take 17 cycles. If you do not have interleaving, then 38 cycles. Now, what happened? So, if there is a cache miss, when cache miss happen, so particular word is needed by the CPU, that the block containing that word is not there in the cache, that is something called cache miss. So, when cache miss happen, then what needs to be transferred? Main memory block will be transferred to the cache memory, okay. So, that is something called cache miss, and for transferring means this is the situation, that block will be transferred. If you use interleaving, then it will take 17 cycle. If you do not use interleaving, that will take the 38 cycle. So, this is something called miss penalty. If there is a cache miss, so there will be penalty. That penalty cycle is like if you use interleaving 17 cycle, otherwise it will be 38 cycle. Now, in operating system class, you will go further more. So, how? So, if data is not there in main memory, so data will be transferred from the secondary memory. So, that is something called page fault. In the same sense, what we are doing here, if data is not, the block is not there in cache memory, we say cache miss. If data is not there in main memory, So, that is something called page fault. Here we say the block, but there we say is the page. Okay. So, but everything in computer architecture class we will be talking about only cache memory and main memory. We won't go beyond of that. We will spend only 2-3 classes for I/O. Okay. So, is it clear to you for why this 17 cycle? So, it is the last chance to understand once more. So, 1 is for sending the address to CPU, 1 cycle. Next is 8 for what? You need to remember here what is the organization. All module will work together simultaneously for transferring the data from here to here. That will take 8 cycle, because first word will take 8 cycle. So, while working for here, this one also is working, this one is also working, this one is also working. So, therefore, that will take 8 cycle. Now, data will be transferred from here to CPU, here to CPU, here to CPU, here to CPU, but it will transfer not simultaneously, only one word. So, this will take 1 cycle, this will take 1 cycle, this will take 1 cycle, this will take 1 cycle. In all together, it will take 4 cycle. But while transferring data from here, this individual module can work parallelly to transferring the second word from here to DVR, here to DVR, here to DVR, and here to DVR. In hardware, you can do the swapping simultaneously, like if you use swapping for say let us say A, B, if you want to, we need to have the third variable, right. Without that also you can do, but you need to do the third variable. In hardware, we can do simultaneously, while data is transferred to one register to another, and you can swap the same value here. So, that is possible in hardware. We will show in, we will assume that one in some other class. Okay, within the operating system, computer architecture class only. Okay. So, therefore, you may have a doubt why I said this one, that while transferring this data from here, it may be overloaded. That is why I said it is possible in hardware, while transferring the data from here to here, at the same time you can transfer data from here to here with using only a single register. Okay. So, now it will take 1 cycle. So, 1 plus 8. Now, what is the task? After 8, that is after 9 cycle, actually 4 words are transferred to CPU. Now, you left about another 4 words. So, this will take here to here, it will take 4 cycle, because it is the second word within the memory module. So, it will take 4 cycle, this one also will take 4 cycle, and it will work in parallelly. So, after 13 cycle, actually only 4 word transferred, and then 4 word are available into DVR. So, that also need to be transferred, and that cannot be done parallelly. So, only one word will be transferred, because it is using the system bus. So, therefore, it will take 1 cycle, it will take 1 cycle, it will take 1 cycle. So, this will be 4. So, total 17 cycle. So, there are some related term is something called, I said earlier, that is something called hit ratio and miss penalty. What is hit ratio? Number of successful attempt divided by total number of attempt. So, that is something called hit ratio. Okay. So, this is, you can write similarly, miss penalty is total attempt for what? For accessing. In earlier example, right, we have seen that we tried to access, we access 20 times, and out of that, in case of the direct mapping, we had success 2. Okay. So, that is hit ratio. Very oftenly it is asked in the exam, because this is whatever we are learning is directly related with exam. So, we cannot avoid. Okay. So, we oftenly ask for a scenario with different program, not the same program which is taught in the class. So, what will be the hit ratio? What happened? The two scenario, if there is a cache data is available in the cache, so that is something called cache hit. If it is not available, so then data has to be brought from the main memory to cache memory. So that is miss penalty. So miss penalty involve that entire thing. So that data CPU already generated the address, so that will be divided if you use the interleaving, and then data will be transferred one by one. So entire time is called the miss penalty time. So then what is the average access time? So there is something called T average is something called hit ratio. So let us say what is we say is the hit. So let us say H is the hit ratio, cache hit ratio, and access time in the cache, because after all that data also will be transferred from the cache to main memory. So that is HC. C is the access time, C is the access time in cache or cache access time. And then if hit ratio is H, then miss penalty will be 1 minus H, and then this is something called penalty M, where M is the M is the miss penalty time. Yes, 1 minus H is the miss penalty. C is the access time. We are talking about the access time. So miss penalty time. Yeah.